Hello and welcome to section 5.6. I'm going to be talking about the hinge theorem today, and indirect proofs will be done in class because they're a little more difficult to explain. Alright, and here's your last page of answers. Okay, as I mentioned, I'm going to be working with the hinge theorem in this video, and then the indirect proof part will be discussed in class. So, here is the concept of the hinge theorem. Let's say you have a gate, and this side is fixed, and this space is fixed. As you open up this gate, what happens to this angle is this angle gets larger and larger. So if you open up the gate much longer or much wider, this angle continues to increase. Okay, so this makes this distance here larger, of course, compared to this distance here. So if you have two sides that are congruent, so the space between the A and the B, and the gate itself, that space there, those two sides are congruent, the included angle that's larger produces a side length opposite that's larger. And that's the idea of the hinge theorem. Let's see. So here's a picture for you guys to show three different gates. As they open up, you can see the BC is increasing, and you can see that angle A is also increasing. So here's our hinge theorem and the converse of the hinge theorem. The hinge theorem is actually really difficult to prove. We're not actually going to prove that in this course. It's just really challenging. So if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. And then the converse goes the other way. If two sides of one triangle are congruent to two sides of another triangle, and the third side of the first is longer than the third side of the second, then the included angle of the first triangle is larger than the included angle of the second triangle. So yesterday we worked with inequalities in one triangle. Today we're working with inequalities in two triangles. Okay, given that ST is congruent to PR, how does PST, that's this one right here, how does this one, I got it, 1 second. Okay, how does this angle here compare to SPR, this one here? Well, this is reflexive, so you have this side is congruent to this side, you have your reflexive side. If 24 is larger than 23, then this angle 1 has to be greater than angle, I don't know why I would put an S there, I should put a 2, angle 2. And that's the idea of the hinge theorem. Two groups of bikers. This is a problem that shows up in your textbook, so I always like to do this one because it's kind of a fun, tricky question. I'm going to recommend drawing a picture like I almost always do. Two groups of bikers leave the same base camp and are heading in opposite directions. All right, so here's our base camp right here. And they're heading in opposite directions. We got two groups of bikers. Each group goes 2 miles. Okay, so they go 2 miles. They go 2 miles. And then change direction and goes 1.2 miles. So they're traveling a total of 3.2 miles. Group A starts due east. I should write this as base because we have Group A and Group B. So Group A goes east and then turns at a 45-degree angle towards the north. Okay, and then they go the 1.2 miles here. So this is 45 degrees. And then Group B starts due west and then turns 30 degrees south. So this angle here is 30 degrees turning south. Okay, which group is farther from base camp? So this is 1.2 miles here. Okay, so the question is directly back to base camp, which group is farther, Group A or B? Now most students will say, okay, well there's 45 degrees, so it's got to be Group A because this is congruent to this, and this is congruent to this. 45 degrees is bigger than 30 degrees, so group A is farther away. But the trick here is this angle in the triangle is 150 degrees, while this angle here is 135 degrees. And so the angle that they give you in the problem is not actually the angle you're using. So group B is actually farther away because of its 150 degree angles versus 135 degree angle. So it's a good question, and you'll see a problem like this in your homework. And then I'm going to talk about indirect proofs in class. They're a disaster, but they're fun and they're challenging, and you're going to love them. So here's their homework. Some of these questions we're going to do as a class. Number 23 and 24. Well, this 23 we're going to do as a class. That is a indirect proof problem. So that's all I got for you guys. Thanks for tuning in, and I'll see you in class.